Hello, everyone. Thanks for the lurk, Sai. Rika. Hey, Nick. Welcome in. I saw you sitting there. Thank you so much for coming. I appreciate it. Oh, shit. I'm so fucking nervous. My feet are actually cold. Oh, boy. So, welcome. Um, this is a long time coming for me, personally. Um, oh, shit. Um, so this is super important to me. Scientific literacy is a big cause for me that I champion, and one of the reasons I got into content creation way back when with a couple of friends over on YouTube was to help educate and to help use this medium to give people information, or even just a perspective. Because how asteroids shape the Earth is not going to be you know is not going to be information that's going to be applicable to your daily life, right? But it gives a perspective, and it's something that is a very big deal to me, is using science to help people understand where they came from, where we're going. There's a lot that can be gained by just having knowledge. Um, and so that's really big for me. Um, I was trying to set up a charity donation thing for this stream and for any of my education streams. But the charities that I wanted to give to are not on Twitch's list of approved charities. So, we'll save that for the future. Because apparently, charities that get more young girls into STEM programs are apparently not good enough for Twitch. But that's not to say anything against Twitch. There's a lot of other things to say against Twitch, but not that. Um, but for today, um, for those of you that have access to my stream VC in Discord, I've made a new VC just for the education streams, and you won't have access to that. So, ha. I realized that was a thing. Mm. Yeah, like there's a couple of them. Like I'm not saying that there's none on Twitch because I looked through the list. Um, but they're very much sort of smaller local initiatives. Um, Probably because a certain streamer lived in that area and wanted to push for that charity. Um, so yeah, that's probably why they're on there. But yeah, the ones that I wanted to support are not in there. Um, I was looking to support fuck where STEM Like a Girl is an amazing organization I was looking to support. Um, they specialize in getting science programs on the ground in lower middle schools. Um, because studies have proven that there are a lot of young girls interested in STEM programs, but they're not reinforced in middle school, so they just feel like giving up. And STEM Like a Girl is a very empowered organization in order to assist. But again, they're not in Twitch's thing, so I couldn't set it up. But that's fine. We'll try to do that for a different one. But yeah, so for this stream, couple of extra ground rules. For chat, I know I'm very, very loose with chat guidelines. I've approved words to be said through Automod that aren't normally something that you would allow. Try to keep it clean-ish. Swearing doesn't bother me. But I see a Sabe lurking in the background, and I'm looking directly at your name. Try to keep things on the up and up. I want this to be an inclusive space, not scaring anybody away. I want you guys to be able to learn, and anybody that wants to come in to be able to learn. If you have any questions during it, there is a 10-point channel redeem. I found it worked better than typing out a command for it. That way I can see all of the questions in my activity feed. But yeah, so asteroids, a very, very important building block of our solar system. For those that don't know, yesterday morning was a very important moment for asteroid science. And we're actually going to start by watching, because I thought it'd be cool. I have the NASA VOD pulled up here. Yesterday, there was a launch from Florida called the mission to Psyche. Psyche is a very prevalent asteroid in our asteroid belt, in our solar system here, because it is 20 to 30% metal. And that's extremely unusual. Iron nickel, to be specific. So the thought is that it's the core of a protoplanet that was hit by an impact, and the crust and mantle came off, and then there's just this core floating around. So we're going to try to go see it, research it, see what's there, see if it has magnetic fields in particular, because that will tell us for sure that it was at one point the core of a protoplanet. Now, the reason that's important is because we can't study our core. We can't study the core of Mars or the moon. We can't get to it. So being able to have one out in the wild like Psyche, if that is ultimately what it is going to be very big for that field of study. So let's go ahead and hop over. Also, again, this is the first time I'm doing something like this. So, scuff. I'm super nervous. If I start rambling, I'm sorry. So, yeah, bear with me. Maybe by the 6th or 7th time this happens, I'll have it ironed up.
Getting down to the final minute now. Now we're going to get the go at T-minus 45 seconds.
Go for launch.
We are go for launch. All systems are go to send the Psyche spacecraft to deep space.
30 seconds.
I was watching this from work yesterday. Not doing my actual job. I was just watching this for like a good hour and a half.
15 seconds.
And here we go with the final seconds of launch. T-minus 10, 9, 8,
It was like the 5th time
7,
I've watched this.
6, 5, 4, 3, 2, 1, engine ignition. And liftoff. Liftoff of Falcon Heavy and Psyche on a mission to a metal asteroid in deep space to study the building blocks of our planet's inner space.
Vehicles pitching
God,
down.
every time I hear that, it's so fucking corny.
M1D.
I love it. It's corny. So, we're not going to watch the entire launch. because this was kind of a special launch. There were a couple of extra steps here, and it took about an hour for the entire thing. Just because of what was necessary to get to Psyche. So it was a little bit unusual in that regard. But the reason I wanted to show that first is because it is very hard to go study asteroids. Obviously, they are, for the most part, out beyond the orbit of Mars. And we can barely get to Mars. So there's a cost associated, there's time associated, there's materials associated. The big question that we have is, why does this happen? Why do we care? So, over the last few years, actually, and kind of over the next decade, asteroid science has and will be taking leaps and bounds of progress. So many different things are occurring. And to give you an idea of what we're looking at, this is a program that you can get on Steam. This is called Universe Sandbox. And it is built by astrophysicists to be as accurate as possible. Now, again, I say as possible because whenever you're simulating something of this complexity, you're never going to be accurate. That requires processing power that we don't currently have. But this tracks every known asteroid, not only in the belt, but some of the major ones outside of it as well. And this just goes to show you sort of the scale here, because this looks like solid white across the board, but you can see all the names are bouncing in and out of existence. There's that many different named asteroids. And here's one here. Ceres is the largest asteroid. In fact, it's so large, it is actually classified as a dwarf planet. It is one of the only ones of its kind within this asteroid belt. Here's Psyche, the one that we're going to. Hi, Riley. And then, of course, there's a number of other ones. And fun fact, you'll see that some of these have like fairly generic names. Like this one's named Charlotte. There's Lydia. That's because back in the day, and I'm pretty sure you can still do this, but it was pretty popular when I was growing up. There used to be a mailer you could get in the Sunday paper that you could send in and like pay $50, and they would track down and name an asteroid after you or your child. So like you have a Penelope. There's let's see, Virginia. So yeah, I'm pretty sure you could probably still do that. I don't know if it's as popular as it used to be. I know there was also one where they would find and name a star after your kid or something like that. But getting back to the main point, again, I'm rambling, I'm sorry. There's been a lot of progress that's been made recently. In particular, back on the 24th, one of my previous streams, the OSIRIS-REx spacecraft landed in the Utah desert, bringing back with it an asteroid sample from the asteroid of Bennu. September of last year, the DART mission impacted the asteroid of Dimorphos in order to test the first steps in a planetary defense system. They took a spacecraft, they accelerated it, and they crashed it into an asteroid. And they studied how its orbit changed, how much of that impact was transferred, and why. So that should they be able to see something coming, they could send up an inexpensive craft and smash it in there and divert its trajectory. Because it may only divert a percentage point or two, but when you're over the course of millions of miles, that percentage point is going to make a difference. In October of 2021, there was a mission called Lucy, which is on its way out to the Trojan asteroids, which are over here. I don't know if they're on this simulation or not. Doesn't look like they are. But the Trojan asteroids are a group of asteroids that have been, two groups of asteroids actually, that have been captured by the gravity of Jupiter. There's a group that is in front of Jupiter and a group that's behind, and they literally all go on the same line. This is separate from all of Jupiter's moons and rings, everything along those lines. Basically, they're asteroid belt asteroids that got caught up in Jupiter's gravity. But because NASA and the ESA and JAXA, the Japanese Aerospace Administration, are masters at multitasking, before it even gets there, Lucy is scheduled to reach the first of its asteroid targets, which is in the asteroid belt itself. I'm trying to get this situated. There we go. Now, I'm not going to try to find the actual asteroid it's going to be visiting. But what it's going to do is it's going to, because of its general trajectory, they're going to pass by two separate asteroids within the asteroid belt before they even get out to Jupiter. It operates as a little bit of a test run, test the systems on the craft, make sure they're operating at capacity, and get some free data. It's going to be passing its first one on November 1st of this year, so here in a couple of weeks. And then the second in 2025 before actually reaching Jupiter in 2027. And in the past, OSIRIS-REx is not the first craft to bring back an asteroid sample. JAXA launched the Hayabusa 2 spacecraft to the asteroid of Ryugu back in December of 2020. It returned with a sample. But again, all of these missions, all of this money, all of this effort, why do we care? Ultimately, there are many answers to that question, right? Some are economic. There was a NASA mission to go out, capture an asteroid, a smaller one, and bring it back to the orbit of the moon so that whenever the Artemis platform was constructed, they could mine it and see what was inside and potentially have a source of resources. Go out, capture an asteroid, mine it to a husk, and let it fall harmlessly to the moon. There's the technical aspect. Can we do it? What technology is necessary to do it? Testing new technologies. This Psyche mission carries a second craft with it. It's hitching a ride that will be testing optical communication. So up until now, primarily, spacecraft have relied on radio waves, which are extremely slow in the grand scheme of things. So if we were to rely on radio communication and we have an astronaut on Mars, on average, it would take about an hour to send and receive one message via radio communication. So one of the things that the little hitchhiker here is going to test is how reliable is optical communication with deep space. Because you get a lot more data in a photon of light than you can in a radio wave. But ultimately, the most important thing that we can get from these asteroids is information. studying an asteroid is the same as studying the Earth, the well, not the moon for a different reason, but the Earth, the solar system itself in general, and its formation. Now, if you want to understand exactly how that works, the story of how asteroids shaped the Earth, built the Earth, and in some ways continue to shape the Earth really simply is quite simple. It goes along with the formation and the steps that formed our own solar system. So, what we're going to do here is we're going to take a step by step look at how the solar system formed, where the asteroids are, how they impacted Earth or early Earth or proto Earth, and move forward through the solar system's formation. Because the story of the solar system is the story of Earth. And the story of asteroids in the solar system is the story of us and our formation. So, we're going to go ahead and go back in time. And we are going to go ahead and take a look at the very beginnings of our solar system. Now, also, for the record, before I actually get into that, ads are still running on the channel. So before we get into sort of the meat and potatoes here, I'm going to go ahead and force Twitch to run its ads. Get that out of the way. And then we'll be able just to roll right into this and have a whole hour to ourselves. So before we get started proper, we're going to go ahead, take a quick break, let the ads roll, and then we'll go ahead and get started. Like I said, if you have any questions, feel free to hit that redeem to ask a question. I'll take a look at those at the end of every section. Try to keep them generally on topic. If something's just blatantly off topic, I won't bother answering it. But pretty much anything science related, I'll be happy to answer for you. All right, so I'm going to go ahead and get these ads rolling. For anybody that is subbed to the channel, I'll put the music back on for you guys so that you're not sitting there in silence. All right. BRB. It would help if I unmuted myself. Hi, guys. Again, scuff. All the scuff. All the scuff. God damn it. You can prepare for everything in the world, but by fucking fate, you're not going to unmute yourself. All right. So, everybody should be back from the ads at this point. So, we're going to go ahead and get started. So, as I mentioned, I forgot to put the title card up. In case you guys were curious, this image, as you can see, is notated there. Side note, I'm going to talk about every image that's in this slideshow because they're really fucking gorgeous. This is the Tarantula Nebula. This was imaged by Webb, the James Webb Space Telescope, on September 6th of 22. Yes. My mic arm is in the way of the preview of the slideshow. This was taken via the NIRCam, which stands for Near Infrared Camera. So the James Webb Telescope is not an optical telescope like Hubble is. It doesn't look at visible light. It looks at infrared light. So it's able to peer through gas clouds and is able to see behind them. And that's why you get such detailed images. This is the title card that I forgot to put up. You guys have been staring at the rules the entire time. My bad. This is the Carina Nebula. It's also called the Cosmic Cliffs. This was the first image sent back by the Webb telescope back in July of 22. Anyway, as I mentioned, if we're going to talk about how asteroids shaped Earth, we have to go back to the beginning of the solar system. Asteroids are the building blocks. They are the little one-piece Legos that you keep stepping on because you have a kid. And their attempted murder. So what we're going to do, as I mentioned, we're going to take this step by step. We're going to talk about, where the asteroids are at this step in the solar system creation. What's going on? How does this change? What's going on? Here you can see a chart of the different quote unquote eras of solar system creation. You'll notice that there is overlap between them. Eras don't necessarily follow a chronological order when it comes to the solar system. A lot of things are happening simultaneously. Not all of these are 100% agreed to either. There is some leeway between them. I'll also touch on that when we get there. But in general, these are the 9 agreed upon eras. So, to kick things off, the pre-solar era. Ultimately, there are 2 different theories of solar system creation. Not solar system, the solar creation. 2 different theories of how the sun came to be. The first of which is fairly straightforward. There was once a supermassive star that exploded, and then its nebula formed our sun and all of us. That one is, ironically, while easier, is not as widely accepted, simply because there's too much stuff. There's too much variety of stuff in our system to really all come from one star. It is technically possible, yes, but unlikely. The other one, which is more widely accepted, is our sun was created as part of a family group, as part of a actual star formation cluster, and was then ousted due to gravitational forces. That one is more widely accepted because it is more likely. Most star formation that we see does not come from old stars, it comes from these stellar nurseries. But regardless of which of those two you actually support, ultimately what occurs is that this nebula of gas and dust begins to condense due to gravity. And eventually, the middle of it gets superheated and turns to plasma. Now, when this occurs, the gravity gets large enough that the rest of the nebula will actually flatten into a disk. This is what is called the pre-solar era. Now, this disk is not capable of nuclear fusion just yet. It is not, by definition, a star. It is something called a protostar. So you can see here that one of these things was actually imaged by James Webb in November of 2022. You can see that the nebula itself is forming this sort of what we think is traditional sort of hourglass shape. And in the middle of that hourglass is a small dark line. That is what is called a protoplanetary disk. That is where all of this stuff is collapsing into. That's where the magic happens. This protostar that's in the middle is just a hot cloud of condensed gas and plasma. It's only about 20 to 40% of the size of our star at this point. Also, as a brief point of fact, the rest of these slides and the rest of these eras are all designated in millions of years after this exact point. This is age 0. It's just easier than doing however many million years ago because wibbly wobbly, timey-wimey stuff. It's just easier to start from 0 instead of counting backward. But yes, this is the pre-solar era. Now, with this, not much is happening here from a asteroid perspective. Not much is happening from a solid matter perspective. At this point, it's mostly gas and some dust, and that dust is starting to clump together. Things are getting hot, which means they're getting sticky. They start sticking together, they start running into one another because they have a lot of energy flowing around them. So at this point, not really much is going on. Now, when we move on, however, this comes into the asteroid era. And I mentioned a bit earlier the DART mission. This is the actual footage from the DART spacecraft. As you can see, it's heading towards the smaller of those two rocks. The smaller one is Dimorphos. This was September 26th of 2022. And basically NASA slapped a camera on the front of it and said, go. And this is what was captured up until the moments of impact. And the video at the end there sort of halts and starts and stops simply because by the time that signal was sent out, the craft had already crashed at that point. So the signal was cutting in and out before ultimately separating. But between 0 to 3 million years after 0, after that, first beginnings of the collapse of the nebula, those first 3 million years are really where things start to get moving. This is where that gas and dust combine into grains, which lead to pebbles, which lead to boulders, which lead to, more and more heavier boulders and rocks and mountains, and eventually getting to asteroids. Now, again, this is an estimate. There's no hard data on it. But given the size of most asteroids we know about, we've estimated that within the first 3 million years, asteroids reached up to 200 kilometers across. Which, for those that speak Eagle, that is about 124 to 125 miles. For those that do not speak in proper measurements and only speak in eagles, just remind me every once in a while and I'll convert it for you. I may live with the eagles, but I don't necessarily speak eagle. Sorry. Now, this is known as the asteroid era, colloquially. This, as I mentioned, is the sort of physical beginnings, especially in the inner solar system. Because after all, gravity is one thing attracting another thing, but it's based on their mass. Their mass warps space-time and attracts bodies. So the heaviness of that ball of gas that is our protostar is going to act on the heavier objects first. So those grains and those rocks are pulled inwards faster than, say, the gas cloud. So that's how you start to see the separation between physical and gas. Those physical grains are going to end up closer to the star. Not always the case. There are other things at play there, namely the density of gas clouds. But by and large, that's how that works. See, and I've already missed a question because I am a fucking shit person. Do you think society will ever get to a point where people across the majority agree on the same theory how it came to be, or do you think there will always be a division between theories and beliefs? So what I would say to that is the differences in theory are not critical. Because having a difference in theory means that both sides of this are coming at it from a scientific perspective. And the great thing about science is that much like humans, science continues to evolve. That's the whole point. We find new information, we come to a new understanding. The issue is, and if you know me, you've probably heard me say this before. The issue is the willful ignorance in belief. It's not a problem if you believe something. At the risk of getting into the weeds here, science and religion are not necessarily at odds with one another. There's plenty of scientists that are religious individuals. It's the issue where you choose to be willfully ignorant of fact and make your beliefs the fact. There will come a point where belief no longer holds water. Now, where that point is up for academic debate. There's a school of thought that says if we were to ever find an intelligent extraterrestrial life or an extraterrestrial civilization, or at least the ruins of one, then that would create a sort of seismic shift amongst humans because they'll no longer, have the sort of general idea they're the center of the universe. But there's also not a guarantee there. The thing about theory versus belief is that theories are tested and either proven or disproven, whereas belief is very malleable and takes on new things as it ages. So there will come a point where there's no more leg to stand on. In words, in education circles, most belief falls into what's called the God of the Gap argument. Because what you find is that their belief takes place in what they don't know. And the more that we learn, the more that we know, their belief just keeps moving further and further back. And eventually, there won't be anything further to go. So I do think there will come a point where majority agree, but where that point is up for academic debate. Thank you for the question, though, Ombre. Let me know if I satisfactorily English. I speak it. If I answer one of your questions, let me know if I answered it satisfactorily, and if satisfactory, we're gonna go with it. And if not, we'll find an answer for you. All right, moving on. So next, we move a bit to the outer solar system here. This, from about 3 to 10 million years after the pre-solar era, we come to the gas giant era. So there's so much gas coming in due to gravity, the star cannot consume it all. There's just not enough gravitational pull yet for that to happen. So what that means is that larger, either A, larger clumps of other gases, or alternatively, a solid object that just pulls gas to it via gravity, ends up creating gas giants. Now, this forms Jupiter and Saturn. And because they're unopposed, they primarily get close to their current size. There hasn't been a lot of change in these gas giants from a size perspective. Now, the theory between them, because the issue with gas giants is we can't tell what's on the inside, right? It's too thick, it's too dense. There's an argument to be made as to whether or not there are rocky cores or not. There's a lot of really complex mathematics at play. The thought is that Jupiter at least has a core of liquid hydrogen. The theory being that Jupiter wasn't supposed to be a planet, but because Saturn was also forming at the same time, Saturn took enough gas so that Jupiter failed to become a star. That's the theory. There wasn't enough gas to go between the two and have a star. Because most star systems are binary. There's two stars. Ours is singular. Why? Well, either A, it was kicked out, or B, Jupiter failed to become a star. Given Jupiter's magnetic field and the heat that it gives off, it may very well have been a failed star. We don't know. More study is necessary. But, fun fact, and we will actually see this. I have another simulation for you guys to see in a little bit. Jupiter and Saturn, you know how they're currently it goes Mars, Jupiter, Saturn. Well, originally they were opposite. Saturn was the innermost and Jupiter was the outermost. And there's a reason for that, and we will get to that later. As far as these images, these are also both from Webb. Saturn, of course, the lower one here, taken June 25th of this year, and Jupiter, August 22nd of last year. These are in infrared. That's why they look different from what you normally see. And in the infrared, you can see Jupiter's massive auroras from its huge magnetic field. The auroras quite literally go around the entire planet. It's honestly, if you could see this, IRL would probably be breathtaking. But the next big thing is solar birth. This is about 30 to 51 million years. This is where the ball of gas has become massive enough, the pressures and the heat are large enough and high enough that nuclear fusion begins to take place. The star is reaching full size, but is not there yet. It is still classified as a protostar until it officially ignites at full force. Now, the reason why this is important is that at this point, solar winds are now being generated by the star. What this does is it begins pushing gas and dust away from the star. So the question of whether or not the star grows anymore is whether or not its gravity can outpace the solar wind. But because of the nuclear fusion, what is also happening is that it is putting force from the inside of the protostar outward. When that happens, it's not always a balanced process. Sometimes there'll be more reactions on the right side than the left side, or the top than the bottom. When that happens, it starts to spin. And thanks to the conservation of momentum, that also causes the disk to spin. So now things are not just slowly lazing around in a generic orbit that will eventually crash into the star. Things are now spinning and orbiting proper. Now, they are by no means stable, but they exist. And this image here is, and I'm probably going to say this wrong because I don't know what original language the name comes from, but Rho Ophiuchi is the closest star forming region to Earth, and it was imaged July 14th of this year. You can tell because each of these pinpoints of light, each of these 6 sort of rayed dots, each one of those is a brand new star that just reached this stage. It just started putting out enough nuclear fusion to shine through the gas and dust. Now, this is where things get interesting. So while all this has been going on, while the sun has been being birthed, while the Jupiter and Saturn are being created, the entire time that is happening, the inner protoplanetary disk is filled with millions of asteroids, billions of smaller objects, and they are all crashing and combining and sticking and clumping and breaking apart, the whole 9 yards. This is called the planetesimal era. Reason being is that this is the time, primarily, it's not the only time, this continues in perpetuity for a while, but this is where all of these asteroids and these smaller objects start to combine together to make what are called planetesimals. Now, that's a big word, and not many people are familiar with it. But essentially, it goes you have full-size planets like Earth and Mars. Then you have dwarf planets like Pluto. And then you have planetesimals are the next thing down. Planetesimals are not necessarily large enough to generate enough gravity to be spherical. But they are much bigger than the asteroids that formed them. And they themselves do have a gravitational field, just not enough to smooth out their own surface. Now, with that, Liam, not today, buddy. Not today. Essentially, what happens here is that these asteroids and these smaller objects form, hundreds of these planetesimals over the course of, 50 million years. And then these planetesimals will continue colliding and shattering and merging and will continue to grow. Now, unfortunately, there's no direct imagery of anything like that because these happen on such a small scale. Even with Webb, we're not going to be able to see it. So this is an artist rendition from an artist by the name of Don Dixon. The only thing I could find about him is that he was born in 1951, but he's done a lot of space-themed artwork. And if you're at all curious, I do suggest it. They are quite stunning pieces, honestly. I didn't know he existed. Like, I'm pretty sure I've seen this exact image somewhere in a college textbook, and I never bothered to look at the artist. It's amazing what VTubing does for you. You start really paying attention to who the artists are. But this is the planetesimal era. This is where, the asteroid era is where things got started. This is where things start to accelerate. You're starting to form these planetesimals. The planetesimals are ultimately going to go on to form dwarf planets, and then ultimately planets themselves. Now, the next big thing comes from our star. Whenever a star is newborn, it officially has enough nuclear fusion happening to be a star proper. The majority of stars, there are some exceptions, but the majority enter what is called a T-Tauri phase. This is where they're essentially, to put it in human terms, they're the toddler that just learned to walk, and now they won't stop. That's essentially where they're at. They enter a period of hyperactivity. Because what's happening is they have this nuclear fusion, which is pushing out, but they now have enough gravity that the gravity is starting to push in and is pushing more and more material together to get more and more nuclear fusion. This is the star, quote unquote, finding the stable balance between the inner forces of nuclear fusion and the outer force of gravity. Now, a side effect of this is the solar winds become far more intense and energy output spikes. Space heats up in the area. Now, the issue with that is that the solar winds now push all the dust and gas, and the smaller asteroids are now pushed away from the central star. The winds strip any sort of primordial atmospheres that had started to form on the planetesimals, possibly even some dwarf planets by this point. Now, when they're pushed, obviously there is drag in the area at this point because of the gas. So the rocky leftovers don't travel as far. They settle within Saturn's orbit, which is our first hint that there is going to be a quote unquote asteroid belt. Now, the dust and the gas primarily gets pushed outside of Jupiter's orbit, which will be important in a minute. Now, this here, this image is V1331 SIG. This was imaged by the Hubble telescope, which is why it's a little bit grainy. It's an optical telescope, back in 2015. But you can see the star is hyperactive to the point that it's actually pushed all of this dust away. Now, there may be planets in here. We don't know. Hubble's not good enough to see that. Especially since this appears to be a system that is, we're seeing top down. Well, quote unquote top down. There is no up and down in space, but I digress. But to show you a bit about what our system would look like, let me grab eventually. Where did you go? There you are. So this is what a T-Tauri system would look like for us. Now, the only thing missing, because I can't do it in Universe Sandbox and have it look correct, is the gas and dust that would have been pushed out. And this is actually getting a little bit into the next phase as well, because you can see a Uranus and a Neptune here. But in a T-Tauri situation, our sun will have pushed the dust and gas just outside of Jupiter's orbit. And you can see here Jupiter and Saturn are switched. But the inner solar system, I put the planets in here to give you guys sort of a sense on where things were at, but these don't technically exist yet. There are probably protoplanets in amongst the giant mess that is the inner solar system, but they're not the full things that we come to expect. So this entire inner region is just filled with asteroids and the planets, of course. All of this is filled up. But all the dust and gas gets pushed to the outside. But this is the next one. This is where that dust and dust and gas becomes important. Between 50 and 90 million years after solar ignition here, Uranus and Neptune form within that leftover gas cloud. Now, due to the gravity of Jupiter and Saturn, they are then flung outward. Not necessarily with enough force to throw them out of the system, obviously, because they're still there, but push them away from that orbit. Sidebar, Uranus and Neptune swap places a lot, and still do. Solar system is not a stable place, even today. But they're pretty isolated where they are. They don't really do or have a whole lot of interaction with the rest of the solar system. except in this one era here. Because they get pushed out, they also push a lot of gas, a lot of dust, and any other little debris gets pushed even further out, marking the beginnings of sort of the Kuiper belt, and the Oort cloud. Basically, like a big shell around our solar system, for lack of a better term, that's just filled with rocky objects. Now, before we get to Umbra's second question, it is about that time for another ad to run, because Twitch. So I'm going to go ahead and run those, force Twitch to run those, and I will get you guys who are subs, well, don't even have to turn over. I'll just talk to you guys. Let's see. But we'll pause this, let Twitch run its ads, and then we'll come back to it. All right, Liam. I'm going to need you to calm down. And honestly, we will get to that, Liam. There's actually going to be a very important thing in a little bit. But I'm going to need you to tone that down just a hair. Thank you. Trying to keep this to be an open space where people aren't going to be weirded out by us so they can learn something. I don't know why I'm getting more and more southern, but it's happening. If I keep going, I'll get to Cajun. All right, all right, all right. Shit. I hadn't even realized we've been going for an hour already. I feel like I'm going really fast because I'm nervous. Reese, don't do this to me. I refuse to get to Florida. I ain't going there. No, no, no. Even a mouse wants out. I ain't going there. Oh, God. All right. All right, so that should be it for the ads. So to get to Umber's question, with the cameras used in space, is there a possibility of using 3D imaging in some way, or does the solar wind pushing stuff into it a problem for accuracy? So, the thing with space telescopes, as well as ground telescopes, is that they're not actually taking pictures. They're collecting. They collect computer data from the various instruments, and they send that back to Earth. And then an Earth team, a group of researchers, either in NASA or JPL, whoever's doing the processing, takes a look at this, takes a look at the data, and goes, okay, well, based on this composition, this is this element, so this piece of data is blue, or this piece of data is red. And then the computer takes those integers and then builds the actual image. So no, the solar wind doesn't have an issue, doesn't cause any issues with accuracy. the sun itself can cause issues, and Earth itself can cause issues with being able to image things. For example, that is why Hubble is essentially just an elongated telescope, and the back of the telescope will always face the Earth so that light pollution from the Earth does not impact imagery. The Webb telescope is the same way. It has these massive solar sails, essentially, that were deployed, and it blocks the main telescope from the sun. That way, the light doesn't affect it, and the sun's heat does not overheat the instruments. But since they're not, now with James Webb, it's not really that big of a deal because it's an infrared telescope. However, with Hubble, having objects in the way is a concern because Hubble is an optical telescope. So, if you're trying to image, say, Mars and the moon gets in the way, that's going to be an issue. But, fun fact, we love fun facts. That actual issue where stuff gets in the way is actually very, very useful. Because for both Webb and Hubble, that exact issue allows the search for exoplanets to actually exist. Because what they do is they point the telescope at a star for the course of a week to a month, or even longer in some cases. And sometimes the light from that star will dim at regular intervals. That dimming tells us that something is passing in front of that star. So then we take a look at some of the other telescopes and we say, all right, was there a gas cloud passing by? Was there some other thing in our solar system happening? No? Well, fuck. That's an exoplanet. So in a fun, weird way, having stuff in the way of what you're imaging is sometimes a very good thing. So that's fun fact. That's how exoplanets are found. First one was completely by accident. They were studying a star and they couldn't figure out why the light kept dipping every couple of weeks. Turns out it was a fast orbiting Jupiter, or a hot Jupiter, as they're colloquially called. Yeah, fun facts. But moving forward, not much is happening here in regards to the inner solar system. Essentially, things are still combining, right? We're still getting further and further along. Planetesimals are becoming dwarf planets, which are becoming protoplanets. A protoplanet is an object that is large enough to smooth itself out and be a sphere, but either does not have a does not have a stable orbit, or it is not capable of maintaining an atmosphere yet. So it's called a protoplanet as opposed to a regular planet. But in regards to Uranus and Neptune, their formation doesn't really have too much of an impact on the inner solar system, or asteroids as a whole, with the exception of they do end up with their movement pushing, and in some cases pulling, some debris with them, and sort of beginning that Kuiper Belt Oort cloud collection of rocks that our sun likes to keep. But the next era is some of the most important events in our solar system. Probably the second most important, really. Most important for Earth, second for the solar system. We come to the main event, the rocky planet era. So at this point, because of the super strong solar winds, because of a large amount of planetesimals, the inner solar system at this point is a very, very volatile place. There's a lot of different gravities at play. Solar winds are pushing things. Ultimately, these remaining asteroids, these remaining planetesimals, eventually coalesce into anywhere from 5 to 7 protoplanets. The actual number is up in the air because of two reasons. Well, one reason, one theory. So during this time, something that's very important to Earth occurs. There used to be a protoplanet by the name of Theia. Theia did not have a stable orbit, and it was about the size of Mars. Ultimately, it is on a collision course with Proto-Earth. Prior to this, Earth did not have a moon. Prior to this, Earth did not have a dynamic core, or at least as far as we know. One of the reasons that Earth supports life is because of its magnetic field. And that happens because the core and the surface are rotating in opposite directions. And it's creating a dynamo. That's why it's a dynamic core. That's why Earth's magnetic field is so strong. Stronger than Mars, and I believe Venus as well. But the only reason that happened is because of this impact between Earth and Theia. Now, based on simulations done by people and computers far smarter than me and far more powerful than what I have here, they've found that in order for this to occur, the two could not have collided head on. That would have destroyed both. Theia hit the Earth at an oblique angle and essentially ground itself into nothingness on the Earth's surface. Ultimately, the Earth absorbed the core of this protoplanet Theia, and all the debris gave Earth a very most likely beautiful set of rings, which ultimately coalesced into the moon. But the impact with Theia also most likely changed the spin of the Earth. Based on the mathematics, if Earth was spinning in the same direction that Theia hit, it would have started moving faster, and we would have much shorter days, if life could have even survived at that speed at all. And if Earth and Theia were at the same speed in opposite directions, Earth would have just stopped spinning. It would have been tidally locked. Which, again, life could still have happened, but it would be very, very dangerous. So what is theorized is that the Earth was slowly rotating in one direction. And then when Theia hit and dragged, it pulled the Earth in the opposite direction and gave it extra momentum. And that's how we have our 24-hour days. Now, again, there's no physical proof of that because after this impact, the Earth essentially had to reform, at least in part. So there's no giant craters or anything. But the mathematics bear this information out. Now, the theorized event is those other two maybe protoplanets were outside of Martian orbit between Mars and Saturn, sort of gathering up things within the asteroid belt and maybe making two more planets. The theory is that those two things collided head on. And the debris was then stretched out due to the gravitational effect of Saturn, therefore not allowing it to reform. Now, it's thought like we talked about at the very beginning of stream, it's thought that Psyche is the leftover core of this explosion, or of this contact collision. There's the word I was looking for. Again, because of how much metal is in Psyche, I mentioned before, the estimates are anywhere from 30 to 60%, which is extremely and unusually high for an asteroid. So, in theory, it's an exposed core from an old collision. But we will know more once the mission to Psyche actually arrives. I believe that's slated sometime in 27 for it to arrive, or 26. One of the two. But, shit, I lost my train of thought because I got confused at what years were. Yeah, so, and as far as the Rocky Planet era, this is where the buildup of asteroids actually matters. 1 plus 1 may only be 2, but if you add 1 plus 1 a million times, that's a lot. And that's basically how asteroids work. Asteroids may, as I mentioned earlier, just be that single Lego in the collection. But when you put a bunch of those single Legos like together, you can build a skyscraper. And over the course of these 100 million years, that's exactly what happened. This is where the physical effects of asteroids making Earth as it is most felt. From a physical perspective, there's still another thing that happened, but this is, the forming of planetesimals, the forming of Theia, the collision with Earth. All of that had to go exactly right in order for Earth to be as it was. If Theia impacts at a right angle to Earth or head on to Earth, both protoplanets are wiped out. As I mentioned, if Theia and Earth had a different relationship between their spins and the impact, life could probably still happen, honestly, but it would be much harder. Tidally locked planets are very, very harsh environments. Fast spinning planets are also very, very harsh environments. So, again, a lot had to go exactly right to bring Earth to where it was now. And this is the first very big thing directly related to asteroids that brought this into existence. Now, of course, it's not the end. There's still far more to be done. But at this point, the Earth is a fully formed planet. It is no longer a protoplanet. It's starting, because of the absorption of Theia's core, it now can generate its own magnetic field, which means it can now protect itself against solar wind, and start retaining an atmosphere. In theory, there probably was a minuscule atmosphere before the Theia impact. There's no way to prove that, but in theory, it would make the most sense. But without a strong magnetic field, those gases would just be stripped off by solar wind. So the merging of the cores, the creation of the moon from the orbit also helps protect the Earth from solar radiation and solar wind. So all of these things put together mean that the Earth can start in earnest once it cools down, because right now it's it's a bit toasty, but still could be worse. It could not exist at all. So the next thing, I mentioned how at the moment Saturn is the innermost gas giant and Jupiter is in the middle. That's about to change. Due to the gravitational differences between Jupiter and Saturn, they are not stable in their current positions. And they end up switching places to where they are today. Now, this causes a lot of issues, namely because Jupiter is so much larger and has such a larger gravitational field, gravitational effect. What happens now is that Jupiter's gravity, let's put it this way, say you're cutting the grass, right? And the lawnmower you have is 12 inches wide, and you're cutting down this, you'll say it's a field of grass, right? And you're having a tough time with it. That's Saturn. Now your neighbor comes over and says, I can help, and comes out with his 20 fucking inch riding mower and just eliminates everything in its path. That is Jupiter. The difference between the two is very, very much a night and day for the asteroid belt. Jupiter and its gravity slingshots hundreds of thousands of asteroids, most likely daily. Now, some of those end up getting captured by Jupiter. Those are the Trojan asteroids. I mentioned they both precede and trail Jupiter. There's two separate fields of asteroids. Some of them get flung out of the solar system. Now they're just rogue asteroids floating in space. Others get flung out to the outer solar system, maybe captured by one of the other gas giants, part of their rings. Maybe they start forming a moon. Others get flung out even further to the Kuiper belt, the Oort cloud, whatever the case may be. But the majority would be deflected into the inner solar system. This is what is called the late heavy bombardment. Now, as a point of fact, we know the late heavy bombardment happened. We know this because of samples brought back from the Apollo program. They brought them back from the moon. Now, the issue, well, it's not really an issue, but it's more of a debate between people that have this field of study, the evolution of planets and the evolution of the solar system. There's a debate going on about how long this era actually lasted. Not whether or not it happened. They all agree that it happened. The question is how long. And the reason this occurs is because Apollo brought back these samples. We know that there was a spike in asteroid impacts. However, the Apollo program only covered about 4% of the moon's surface. Which, to be fair, on the moon, 4% is a lot. But when you're talking on the scale of something like the heavy bombardment, 4% of the moon is nothing. It's not enough data points to really concretely say, yes, this happened for this period of time, and that's the end of the story. So the hope is that with the Artemis program and the creation of the Artemis station, having more of a permanent human presence on the moon, that we'll be able to get more information. But ultimately, this era has a very big impact on shaping the inner solar system. it's thought that Mars's moons are captures from this heavy bombardment era. Um, a lot of the big impact craters that you see on the moon and on Mars are from this bombardment. Now, of course, you can't see any of the craters on the Earth, simply because of weathering over time. But you can see them on the back of Mercury. And we have imaged those, and they are massive. Now, with that being said, the impact of the bombardment, Earth was already primarily at its current size, right? So the late heavy bombardment did not increase the Earth in any way. However, I also mentioned earlier that the inner solar system had a lot of solar wind and it was very hot. Because of that, no icy materials could exist in the inner solar system. By icy materials, what we mean by that is materials that are normally gases or liquids at regular temperatures that would then freeze in space. So, water, CO2, hydrogen, oxygen, etc. And on top of the sun, Earth was still cooling from being impacted by Theia. So, there's no water, no CO2. Now, there are some theories that say Earth still would have had water, just in a subterranean manner. That is possible. It's up for debate. We don't have a lot of information on it. More study is needed. But for now, the generally accepted theory is that the asteroids that were bombarded during the late heavy bombardment brought the first, well, not the first, but brought a new source of water and other material. And, fun fact, we recently got confirmation of that. Not so much confirmation, but we got a new piece of data. So I'm going to show you guys. Where did it go? I mentioned earlier that last month we recovered the Osiris Rex capsule. I streamed it. And 2 days ago, this happened.
And it's giving us a glimpse into what lies beyond. So 7 years, almost 4 billion miles of a journey.
For those that are unaware, this is NASA Administrator Bill Nelson. He's done a lot for the agency, especially when they were being hounded by Congress for wasting money. But he's done a lot. He's a cool dude. He's just a little long-winded, so I skipped most of his speech.
Throughout the solar system to the asteroid Bennu, now back in Osiris Rex, the sample return capsule landed in Utah, right on the money. It was a picture-perfect mission. It's a feat of engineering.
For the record, it was not a picture-perfect mission, but we'll get to that in a minute.
And it's NASA's first ever sample from an asteroid. So, you ready to see the results of the mission? Take a peek. So the first analysis shows samples that contain abundant water in the form of hydrated clay minerals, and they contain carbon, and you could see the carbon there as both.
Okay, so I'm going to pause him for a moment. The reason why I say it wasn't a perfect mission is that you can see in the top left corner here, there's little, like you can see little pebbles, little rocks in the top left. This canister is supposed to be sealed to this lip. This debris should not be here. But these rocks, whenever whenever it lifted off with the debris, these rocks got caught in here. This cavity should not exist. Ultimately, it didn't cause any issues with the actual mission. It got stowed safely. It didn't cause that much. It didn't cause an issue. But it was not without fault.
Minerals and organic molecules. And at nearly 5% carbon by weight, carbon being the central element of life, a far exceeding our goal of 60 grams. This is the biggest carbon-rich asteroid sample ever returned to Earth. Carbon and water are molecules. The carbon and water molecules are exactly the kinds of material that we wanted to find. They are crucial elements in the formation of our own planet. And they're going to help us determine the origin of elements that could have led to life. And I mentioned that one of our missions, it's actually in statute, is to look for life. That's why we're digging on Mars. That's why we go out into the far regions.
Okay, so he's just going to keep talking. So I'm going to stop him. Again, he's a super good guy. Super long-winded. So the reason I play that clip there is because the Osiris-Rex mission came back and it definitively showed what's called wet clay, which means it's silicates that are bound together with water molecules. It doesn't mean it's actually wet. You can't squeeze it and get water out of it. But it means that these silicates are bound together with water molecules. Added to the fact that it's a 5% carbon sample, that is more than enough carbon to facilitate chemical reactions. One of the reasons that we are carbon-based life is because carbon has a number of free electron slots that make it very reactive. Silicon is the same way. That's why that's why scientists state that if there's something that isn't carbon-based life, it's probably silicon-based life, because silicon is in the same group, it's in the same column on the periodic table. It has that same property and is still abundant enough that it could possibly lead to life. Fun sidebar, there was a computer simulation of what the DNA structure of silicon life would look like, and oh boy, was that cool. It was a quad strand structure as opposed to a binary helix, and it was so pretty. Anyway, back to the point. So this shows that there is water molecules in asteroids. So, for example, if we take Bennu, where that sample came from, and we crash it into Earth, the heat from the impact is going to free those water molecules. It's not a pick, it's just a simulation. But yeah, it was pretty cool. I'll see if I can find it. It was a while ago. Anyway, so like if we take Bennu, right, we smash it into Earth, the heat is going to force the water out of that clay. Any ice crystals that are on the inside of the asteroid are going to vaporize, and water will be released. Now, an important note, as I mentioned earlier, Earth now has a strong magnetic field because of the Theia impact. So the solar wind is no longer pushing these gases off the planet. So now that water can now exist, and it will start to cycle. So everybody knows the water cycle from school. Water condenses into rain, falls down, runs off, and evaporates, and continues the entire cycle. That has to be kickstarted somehow. And even if there was underground water on Earth, it's still underground. It needs to be brought to the surface. These impacts would have done that. It would have caused volcanic eruptions across the planet. It would have caused earthquakes across the planet. The crust would crack, it would break. Anything in the subsurface in these regions would be brought to the surface, thereby releasing more water and more chemicals. And then from there, it's just a matter of time. The reason being is that water is a very stable molecule. It's also very corrosive. So the water molecules that are there then start binding to the chemicals that are already being spewed out by the by the volcanoes, by the dust kicked up by these asteroids. And the dust from these asteroids blots out the sun. The same thing that killed the dinosaurs, right? The asteroid hits. Some dinosaurs are roasted from the impact, others from the massive tsunamis that would follow. But primarily, many more died because the dust from the impact blocked out the sun, or most of the sun, and dropped Earth's temperature. Same thing would have happened here. Earth is still cooling. It's not cold enough yet for water to stay on the surface in a liquid form. But by blocking the sun with the water that's already there and the ice that's already there, yes, you're going to get a spike from heat from all these impacts and all these volcanoes, but those are going to stop. And then ultimately, you start that water cycle again. So even if there was water under the surface, even if not all of the water came from the asteroids, without the asteroids, Earth is at an impasse. Either it's random chance that a volcano breaks open a water vein, or these asteroids broke the water vein. Either way, it happened. And because Earth has an atmosphere now, it's able to start regulating its own chemicals. And it begins. The earliest forms of life that we have evidence for occur almost immediately after the late heavy bombardment period. About 600 million years after the sun's birth, 6 to 700 million, there is evidence of ancient microbial life. So somewhere in that time period, the right chemical reaction occurred at the right time, and now this new living thing has no competition whatsoever, so it spreads like wildfire. Now we have life. And on a side note, the asteroids bring more than just carbon and water. They bring radioactive material. They bring iridium, uranium, and all of the other radioactive chemicals. Some are probably already in the Earth, but a lot are most likely brought by these asteroids as well. Which sounds like a bad thing, but keep in mind that some places, or the Earth's core itself, is also fueled by radioactive material. So it elongates the lifespan of the Earth, at least in some way, shape, or form. And from there, allows life to flourish. This is the single largest movement of asteroids, largest movement of material that is not caused by the sun. And besides the Theia impact, it is the most important one, at least for Earth. Now, from here on out, asteroids begin to play a less and less vital role in the Earth. Besides a couple of odd, asteroid strikes, not much happens. Things sort of enter a period of semi-stability. Earth has had a number of mass extinctions, but the only one that's been confirmed to occur from an asteroid is the Cretaceous tertiary extinction. That's the dinosaurs. So it's really the only time after this that asteroids impact the Earth. And ironically, it is the one extinction that allows for humans. All of the other ones don't result in humans being dominant. They don't even cause humans to exist. But the death of the reptilian species allow for the proliferation of mammal species, and therefore of us. So thank an asteroid today that you exist. It's got to be a bumper sticker somewhere, right? Thank you, asteroids. So somehow, some way, I've talked long enough that another ad is coming up. That doesn't feel accurate. But I also can't argue with Twitch. So I'm going to go ahead and force it to run the ad. We have one more section of our education stream here, as far as looking forward to the future. So we're going to go ahead, hit the ad break. I'll see you here. I'll talk to you guys still. And yeah, we'll go ahead and hit up the last section of our little education stream. Eventually. There we go. It's running the ad now. Twitch confuses me recently. Because, now it's only running 2-minute ads, but I also don't feel like it's running an hour in between them anymore. I don't know. Shit's weird. Yeah, bruh. Yeah, I'm not nervous anymore, but my feet are still cold. But, ow. Yeah. Listen, this has been a long time. Water? Yes. Water. That was the pop top for water. I know. My only complaint is that I'm super nervous. And so I'm not really comprehending what's happening. I'm just talking. I gave myself a ridiculous time crunch on this. I really should not have. I was so focused on putting this around all of the asteroid news it I really underestimated how much work this was. Um, like I just finished writing this PowerPoint, what, on Wednesday, and I just made uh nerd. Yeah, well, that's fair. Um, and I just made because I realized that I had forgotten to make an OBS scene for this, so I just did this OBS scene earlier today. Um, so yeah, like this has been a long time coming for me, and I'm really pumped about it, and I want this to like continue as long as people want it. Um, honestly, I just reused the the layout from my NASA watches. I just reused the same thing. Um, like I want to cover a whole breadth of topics, and I'd really like to have input on what comes and what I do. Because like if I just start picking shit that I'm interested in, then there's not really a point. Because I want to give people information they're looking for. Um, but yeah. Anyway, ads are over. So yeah, it's only doing 40 minutes between ads now. It's weird. Anyway, so into our last little section. What now? Um, so we've covered how asteroids shaped the Earth. We've covered how they paved the way to the conditions that we see. But what's the point in studying them now? All of this stuff has already happened, right? Well, as I mentioned, it's about studying us, right? It's about studying our planet and planets in general and how we came to be. Yeah. I need to go in, yes, Riley, I need to go in and figure out what the fuck is going on because I specifically have it set for no pre roll ads and it's still happening. And that pisses me off because I hate pre roll ads. I do. So I need to go in and double check those settings and see what's up. But anyway, um, so with that, we're trying to study where we came from, how we were formed. How do we do that? Well, the good news, space is a vacuum. So unless there's external influence from something, not much is going to change. Um, yes, asteroids are constantly in a heating and cooling cycle because they also face the sun. They heat up slightly. As they rotate, they cool down, and that can cause outgassing and the loss of other things. That's why the asteroid belt is not really all that stable because one asteroid randomly outgasses and it propels it into another asteroid, and then you have this billiard situation, and boom, dinosaur go bye bye. Um, so the primarily speaking, though, most asteroids are in their same orbital pattern that they were at the end of the bombardment era. Because once Jupiter cleaned house, that was just kind of the end of it. Um, therefore, most of them are in the same state as they were when our solar system entered this period of pseudo stability. But others may have also survived from the very era of asteroid formation itself, or are fragments of a planetesimal collision from the planetesimal era. It's those older ones that will give us a look into how the Earth was built, how the solar system came to be, how we can find a more complete picture of how we or the Earth survived this roulette of possible destruction to evolve as we have. And again, Psyche is a very, very big step in that direction. We talked about it earlier twice, but it's worth noting again, if we can prove, say we go to Psyche and we find it has a magnetic field or the remnants of one, that would prove it was a core. We can then plan another mission to go back to it with heavier equipment and grab a sample, just like we did with Bennu. Only this time, instead of a sample of just confirming water, confirming carbon, we're able to possibly drill a core. You can't do that on Earth. You can't do that on the moon or on Mars. You can't drill into the core of the planet. The pressures are too high. It's too hot. It's not physically possible. So by being able to do that on Psyche, possibly, we then have a concrete view at the core of a planet. You're never gonna get that again. Unless your civilization's advanced enough to gather energy from galaxies, which would be a type 2 civilization, I believe. No. Type 1 is a planet, type 2 is a solar system, type 3 is a galaxy. A type 3 civilization would be able to sort of run planets together and see what's inside of them. So this is a very unique opportunity for us. And the fact it's one of the oldest known asteroids, its technical name is 16 Psyche. It was the 16th asteroid ever discovered because it's so reflective. It really is a look into the past. And honestly, there's not really anything else like it that we've seen. But speaking of the future, it's probably a good idea to go over some of the future asteroid missions, because there is a lot coming up, comparatively speaking. So, November 1st, Lucy, which I mentioned a bit earlier, will be doing a flyby of one of the Dinkinish asteroids. September of 2024, JAXA, the Japanese version of NASA, will be launching a mission known as MMX, Martian Moon Retrieval, I think, when it's translated into English. They're going to go to the Martian moon of Phobos and retrieve a sample from it. Now, the reason I still included it is because Martian moons are not actually moons. Martian moons are just asteroids, but they were captured by Mars. In October of 24, ESA, the European Space Agency, will be launching their Hera craft. Hera is strictly there to study Dimorphos. Because right now they have Hubble looking at Dimorphos, and that's how they're figuring out how DART impacted it. Hera will be going up to study that in detail. And then once they have that data, it's going to move on to a different mission and start studying other asteroids. April 20th of 2025, Lucy will be doing a flyby of the asteroid Donald Johansen. That is not a typo. That is its actual name. It's an asteroid that was found by a amateur astronomer, so he got his name on it. It's not particularly of any big scientific interest, but since Lucy's flying by already, you might as well snap a few pictures. And August 12th of 2027, Lucy will actually arrive at its main target, the Trojan asteroid fields. And then in 2028, it is planned, it's not yet fully funded, but it's planned to have the Near Earth Object Surveyor mission launch. What its goal is to do is to catalog up to 90% of what are called near Earth objects. Near Earth objects is anything more than 150 meters in diameter that crosses Earth's orbit in some way, shape, or form. It does not ever have to actually be danger of contacting the Earth. It just has to cross Earth's orbit to be classified as such. So they're going to try to survey those, see which ones are dangerous, see which ones are not. And the whole point is to keep an eye on them, to study them, study their orbits. And if something is a danger, possibly another DART mission to make it not a danger. So very, very much things to look forward to over the coming decade. And of course, with, NASA's Artemis mission, shooting for the moon, getting a permanent human force in lunar orbit, much more science is to come, because they're probably going to also be, exploring the moon, mapping it out, getting samples from other craters, bringing them back. The one thing that is sad news on the asteroid front, though, and I mentioned it a bit earlier, is that NASA did have a mission to go along with the Artemis program to send out a craft to capture an asteroid and then bring it back. While that mission was in development, it was defunded by the previous White House administration. So maybe it comes back. Who knows? But hi, Mac. Welcome in. Just managing to tag your just managing to catch the end of what we're going over today. But shit, now I got distracted. Oh yeah, it was a planned mission to go bring back an asteroid into lunar orbit. They would study it, mine it, prove that that is a feasible thing to do, and then crash it into the moon. But again, it was defunded by the previous White House, so who knows if that will come back. If it does, great. It's a really cool idea, and it needs to happen anyway. But who knows? We'll see. But for now, these are the planned future missions for around the world. Now, there are probably other ones. We don't get information from the Chinese Space Administration or the Indian Space Administration. Or the Russian space program. So there may be more asteroid missions that, as geopolitics plays out, we're not going to get into it, but scientific communities don't really care about politics. They normally just communicate anyway. But in some countries, space programs are very secretive. So we'll see. Possibly changes. Question from Rixa. Do the orbital paths of asteroids impact each other? And if you removed a significantly large size asteroid, would you end up altering the orbit of other asteroids? Yes, and yes. So asteroids impact each other constantly. It's very much a billiard situation. Because the thing is, in space, you don't stop until you hit something. So this one asteroid may have been bumped. Asteroid A may have been bumped by asteroid B 200 million years ago, and it's just been floating on this new path until it eventually nicks asteroid C, another 50 million years from now. So yes, absolutely, they do impact each other. Most asteroids do not impact each other gravitationally because they're not big enough. However, there are a number of larger asteroids that don't quite meet the criteria of a dwarf planet, but are still larger than a normal asteroid, and they do have a gravitational pull. Now, the downside is that we will never see the building of another planet, at least in the asteroid belt, because Jupiter's a prick. Jupiter's gravitational field is not disturbing the asteroids any further, like it's not launching asteroids at us, but it is still strong enough that it will stop the formation of other planets. So, yeah, that's a thing. So, and to segueing into the second part of the question, for example, Ceres. Ceres is the largest asteroid, so much so that it's actually classified as a dwarf planet. It's actually completely spherical. It has enough gravity to do that. If you were to remove Ceres, it would destabilize orbits of neighboring asteroids. That's exceedingly rare, but definitely possible. Now, if you were to go to, that information only applies to the asteroid belt itself. So, like, for example, the Trojan asteroids, if you remove one of those, doesn't matter because they're held in place by Jupiter. If you go out to the Kuiper belt or the Oort cloud, that also wouldn't have an impact because they're so spread out, they don't actually particularly interact with one another. So, again, that only applies to the asteroid belt itself. But as far as the information we have today, bleh. That is how the asteroids shaped Earth, which ultimately coattails on a lesson on how the solar system formed because they are very much one in the same. So you got a twofer. It's one of the reasons why I was kind of excited about doing this because, you learn about one thing, but it connects so heavily to another thing, you end up learning both. I did, for those of you that are part of the Discord or wish to join the Discord, the link is in my panels. There is a new text channel. Yes, text channel for topic suggestions. So if you have something you want to see me go over, put it in there. It'll go on the list. If you see something you're interested in, go ahead and react to it. That'll help me determine what happens next. The more reaction something gets, the faster I'll do it. As much as I would love for these things to be a regular occurrence, I don't think I have the time or the mental fortitude to actually accomplish that. This was a lot more work than I expected it to be. and I gave myself a time crunch. And like I personally feel like there was more I could have did here. I just didn't have the time to do it. Um, that may just be me being a pessimist, but yeah. Um, so the next one, uh, whenever that happens, will probably be hopefully a bit better put together. But yeah, thank you all for hanging out and coming to, I was super nervous that nobody would actually like A, enjoy, or B, care. Um you're welcome, Misa. Yay. Um but yeah, um if you guys have questions, like science related questions, you can always drop them in my Discord or ask me on stream. I'll be more than happy to answer any questions, even outside of these little things. Whew. I feel really relaxed now. All of my nerves have gone away. Oh boy. But yeah. Does anybody have any like other questions? Because I know we had a lot of people came in right near the end. Um, the VOD for this will be going up on my YouTube channel, which I have set up as of 2 days ago. um, and it will also go up on VStream as soon as VStream allows video uploads. Um, that is on their roadmap. Um, Once that happens, I'll primarily be putting them on VStream, mostly because I don't particularly like YouTube. But yeah, for now, it'll be on YouTube for anybody that wants to watch later. Whew. I think that's it. Oh, I would also be remiss if I didn't mention um, the little bottom message on the screen there. If anybody likes reading and wants to help, let me know, and I will add you to a Discord chat. I'm looking for people to be a focus group and to proofread a novel that I'm looking to publish. Um, yeah, if anybody's interested. Uh, let's see who's on at the moment. I now have like 3 different tabs that all point back to myself because everybody that I had tabbed rated it or just stop streaming. uh, what's what's in the science and tech area? What's going on? Anybody else? Anybody doing anything interesting? No. Yeah, okay. Oh, then I guess. Hmm. Oh no, I don't have any sort of deadline or anything like that. Honestly, since I added you and Umbra to that, I have not even looked at the document. Uh, um, and yeah, I've been focused on other things a lot. I probably won't look at it until sometime in December. So yeah, no, you're fine. If you do find anything as far as proofreading, which you probably will because it's not my strong suit, um, once I go through and like find it and either correct it or comment on the comment, then I'll just delete it so it doesn't take up too much space. But yeah, no, that's fine. Take your time. It's not relevant. I'm not important enough to take up that much of your life, Rixa. So we're gonna go ahead and raid Psy. Sandonian is currently playing Escape the Black Room back. Jesus Christ, really? What the fuck? Escape the Back Rooms, which is a horror game if you are not comfortable with that. But he's been lurking in the background. He is actually a proper educator. He is a math teacher. So he gave a lot of support to this idea. And yeah, he's also a cool, chill dude. So we're going to go ahead and raid into him. I will probably stream tomorrow because like I focus so much on this, I forgot to schedule D&D. Sorry guys if you're here. So I'll probably end up streaming tomorrow night. But yeah, I'm sorry, I'm just really relaxed right now and I don't know where my brain's going. But we're gonna go ahead and raid Psy. Show him some love because he's cool peeps. Yeah. Did I ever say how much I love you guys? I love you guys. Thank you for putting up with my bullshit and letting me have fun. Okay, babies. Have a good night, day, evening, whatever your current temporal reality is. I will see you guys later. Peace.